Good afternoon, everyone. My name is Rick Drucker, and I'm the Business Development Specialist at Lesman Instruments Industrial Hygiene and Safety Division. I'd like to thank you all for joining us for today's webinar on advances in noise dosimetry, survey, and continuous monitoring applications. We're going to cover a lot today. Today's presentation will discuss the latest advancements in dosimetry for both IS and non-IS models. Questions will be addressed regarding audio recording, voice memos, octave band analysis, ceiling counts and reporting, expanded logging variables, increased virtual meters, expanding Bluetooth, enhanced mobile apps, and more. Today's speakers will be Jason Rutz and Komi Toviau from TSI Quest. Jason is a product manager at TSI, where he is responsible for managing go-to-market and downstream product support for occupational health and safety instruments and tools. With over 15 years of experience in manufacturing for various industries, Jason possesses a robust technical product development background. He joined TSI in 2021, where he and the team have continued to build on the trusted TSI instruments and tools that the industry has come to know. Komi is the product specialist for Health and Safety Quest at TSI, with a background in electrical engineering and instrumentation. Komi is the technical subject matter expert for TSI Quest's product portfolio, and his responsibilities span over customer relations and satisfaction. We welcome both of our speakers and thank them for sharing their time and their expertise with our customers. Just a note that during our seminar, we've muted everybody's microphones, but we do encourage any questions you have. So please, if you could just type them into the question box on the Go to Web toolbar. We'll either try to weave them in or we'll address them all in the Q&A section at the end. So with that, I'd like to welcome Jason and Komi and turn the floor over to them.
Thank you, Rick. I appreciate the introduction. As Rick said, my name is Jason Rutz. I'm a product manager here at TSI. I'm very excited to partner with Komi today to talk about our new Quest Edge 7 and 8 dosimeters. Lots of exciting things coming out with these new products, and that said, we'll dive right into it. Okay, so we'll go through a quick intro, talk through the key features. We'll do a little bit of a value walk through the features, give you some examples of how they're used, go through a little bit of the technical detail. We'll also talk about our DMS reporting software, and then at the end we will of course answer any questions that you guys might have. So the new Quest Edge 7 and 8 dosimeters are really the latest addition. So TSI has been doing noise and sound for a very long time. The Quest Edge 7 and 8 are a coming together of all the stuff that we've heard from the market over the years and what we've learned from our past dosimeters. And what we're really releasing here is the most powerful and durable dosimeter that TSI has ever released. We'll get into a little bit of details here, but one big thing to note with our dosimeters is they come standard with a powerful and complete package of features. To talk about that a little bit more here, you can see some of the core features here that are included. So a lot of features with some of the competitive products have pay-to-play aspect to them, if you will. So what one-to-one octave band analysis, audio recording, voice memos, certain things that aren't available, such as ceiling count, configurability, the DMS analytical software, the iPhone and Android app capability. We've incorporated all that into these devices, and it's one price for the entire package. So, excuse me. There we go. So diving into multiple studies here a little bit. So the administrator can run studies with the OSHA PEL, OSHA HC, ACGIH, and custom, so that they can monitor up against 4 different standards simultaneously. So the custom study gives the administrator the ability to run tests outside of the established standards, measure against location-specific requirements. For example, we've heard that some companies specify parameters below or above noted standards. These companies can specify these lower standards to ensure that the health and safety of their workforce is being enforced. They can also build custom settings into other established standards such as ISO or MSHA. And all these can be named and saved for later, so you don't have to go in and reconfigure them every time. So,
yeah, I should add that we've seen this being very useful in the field because when you go out and do surveys, it's better to do the survey for the same noise and compare it against different standards versus having to measure do one survey against one standard and so forth. So this is a time-saving tool that allows a lot of our users to kind of compact all their surveys into one file while comparing different standards against each other.
all right, so voice notes allows the administrator to more efficiently capture verbal notes about location, description, noise events. So this must be activated in DMS, right? Which means it can be deactivated in DMS as well. So this gives the administrator, the ability to manage multiple measurements during the study. The administrator can capture multiple noise samples within a session and leave notes for reference during later analysis. Voice notes after an audio event are great for reference and post-study analysis. This really eliminates the need to carry a notepad to manually capture additional field data, which you then ultimately need to, tie back to an event within the data, or I'm sorry, a time within the data. So ultimately creating efficiency. Right? So as you can see on the screen here, where that little blue line is pointing, that's referencing where a voice note was captured, and that is overlaid with the data on this DMS screenshot that you're seeing. So it's all co-located in one location.
And one other thing that you can see on the screen here is the hierarchy of control that's at the top of the screen there next to the voice note. And really what that tells you is how this might be useful, or how we've seen the requests from customers or the users in the field. So these are, for example, elimination and substitution and engineering control. As you're going around and doing spot checks and doing surveys, typically what you do is you keep a notepad and take notes of who you sample, the location, and all that information. The issue is sometimes you might not be able to get back to that same study until a week later or 2 weeks later because you're somewhere else doing a heat stretch, survey or a gas survey somewhere else. So having the ability to take voice notes that are accessible right on your device is a very useful feature that expedites the process of the hierarchy of controls.
Yeah, and before we move on, I should point out the upper right-hand corner of that screenshot. You can see that little play button. So you can highlight a specific voice note, play it back for quick reference. All right. Now we're going to talk about audio event recording. So these audio recordings are reviewable in your timestamp data set as well. You can see the little blue line pointing to the event right next to it. So you're going to have voice notes and audio event recording, right? So this can also be very helpful in determining sources of sound events. So for example, you might be at a construction site, you'll see a spike, right? And you might not be sure what that's related to. It could be machinery or an outside source, such as a train or an airplane. By referencing this, you can see the spike in the data, you can play back the audio event recording, and it'll help you understand what was happening there. That way you're not sometimes guessing or having to go back in some cases and reevaluate in order to understand where what was causing these outliers. And these can be set at different threshold levels and durations, which I'm going to allow Comey to talk a little bit more about that.
Yeah, and what's really important about these automatic audio recording is to first and foremost, you can enable or disable this particular feature in the software. We'll go over that later. But as Jason pointed out, when you set a threshold for 100 dB, for example, for 10 seconds, when the noise level reaches 100 dB for 10 seconds, it triggers the automatic audio recording, but it doesn't start at 10 seconds. It backtracks it from when it first started. so you can get the full picture of what caused the noise or the spike in the data. Because oftentimes when you come back and do an analysis of the data, our software allows you to kind of recalculate or eliminate the areas of your surveys that you don't want to be part of your calculation. But it is sometimes a risky approach, because you really don't know, you can't really assess what that spike was, triggered by. So this really eliminates the need of starting over or doing another survey because of the unknown here. And the hierarchy of control there is there to show how one or how some of the users are have been requesting the automatic audio recording being used in the field as you go through elimination or substitution and even engineering control. When you redo the survey to test whether or not your implementations have been successful or not.
So, yeah, and a couple pieces of feedback we sometimes receive on audio event recording and voice notes are, can they be turned off? As we've noted, yes, they can be turned off. The other piece of feedback that we hear is this going to be recording my conversation? So, as we noted with audio event recording, you're setting at a threshold that isn't sustainable for somebody speaking to do for a duration, right? So it's not going to capture conversation. It's going to capture loud anomalies in noise, and only when those loud anomalies in noise hit the threshold in which you set. So there's no concern with capturing conversation within a work environment. And with voice notes, not only does it need to be enabled, but you also need to press a button on the side of the unit in order to capture that voice note. So kind of like a walkie-talkie, if you will.
So the user have control over that as far as the voice note goes.
Right. Okay. All right, we're moving on to pause study. So pause study allows the administrator to keep their session data cleaner. So, for example, in addition to pausing during breaks, shift changes, travel, the administrator can also pause when doing sampling of a given area, which eliminates the need for multiple sessions tied to each sample. So this will also benefit the user when doing sampling over several days, as the pause feature can be used for unrestricted time frames. So one thing I want to point out here on this screenshot here is you're now seeing voice notes, you're seeing audio event recording dots, you're seeing the study information, and you're seeing pause between the breaks right there. So it's really showing how all these features are kind of coming together to show you everything in one place for easy analysis post-study.
Yeah, so the pause study here has been for a long time a big request in the market, because usually when safety professionals sample their worker, it's usually not for 8 hours straight at the same spot, right? It's usually sometimes a 2-hour session here, and then a 3-hour at a different machinery, for example, and then back to the original spot for a couple more hours, right? So the pause study allows you to capture all that information in one file, right? So, and as you do the pause and move along with different stations, you can perform the voice notes that we mentioned earlier to remind yourself of who you sampled, what happened, the date and the location, and so forth.
All right, so ceiling count. So ceiling count threshold allows you to monitor both values and count of occurrences above a ceiling decibel level, right? So an example of this is the user might be exposed to peak levels when they're working on a specific pieces of machinery or within certain areas. The administrator can use the ceiling exceedance calculation, which will offer them additional guidance on additional controls, such as hearing protection that might need to be implemented during a particular task or for a particular worker who has some specific job duties.
So this is, for some of you might know what the upper limit is, and this is something that OSHA has in their standard. The upper limit really is a noise that is counted for every second that it's triggered. So when you have a 110 dB for upper limit, it'll count it every time, every second, right? That happens, and there's really no way to change that a log interval to suit your needs. While the ceiling count gives you a flexibility to not only change the threshold, but also the trigger time. So if you want to know how often this particular noise level or threshold is being hit during a particular study, the ceiling count can allow you to see that. And again, the hierarchy of control there shows you how one might go about using the ceiling count here, whether it be through elimination or whether it be performing subsequent studies to check whether or not the controls are working successfully. So, yeah.
Okay, next we'll talk about octave band analysis a little bit here. All right, so this octave band analysis allows the administrator to determine the most appropriate hearing protection device based on specific and individual variables at the user's ear. So this device is attached to the lapel right next to the person's ear. So a user might be exposed to different exposure levels within each octave band. Tailoring hearing protection to protect against user-specific variables will provide better protection versus a single area decibel measurement. So essentially, the octave band attenuation method allows the administrator to more precisely determine the best hearing protection for each individual. So by using one instrument to capture noise as well as frequency data, octave band here, this saves time and money by lessening the dependence of an additional SLM with octave band capabilities.
Yeah. Currently, so far, in the market, there's a lot of safety professionals or industrial hygienists are familiar with octave band being used on sound level meters for spot check. I've seen people use it for when they respond to a noise concern to determine what are the highest frequencies in a given area. The good thing about having octave band on a dosimeter is that you're now taking the frequency and dB data to the person's ear. So that really plays a big role when determining the appropriate hearing protection device to be tailored to the particular individual. The hearing protection, on the other hand, most of them have a single number rating or an NR that give you the rating value that they are the nominal rating value. However, the ISO standard recommends octave band as the most accurate method to determining the appropriate hearing protection device for the individual. So when it comes to hearing protection devices, it's really not one solution fits all, and the octave band allows you to tailor specific solutions to each individual. Now, this slide here shows you how that might translate in the software. So as you can see here, you have the L average and the graph next to it. So the L average is what's shown on the y-axis that's a vertical axis, and the dB values are what the L averages are. And when you look at it, you see that from 500 dB to let's see 4 kilohertz. Oh, sorry, from 500 hertz to 4 kilohertz are the highest frequencies that we might be concerned about here. So this is a quick way to figure out whether you want to tailor this to a hearing protection device or a particular machinery. This is a quick way to eliminate your target equipment and so forth. This same slide shows you the ability in the software also not only to select the L average, but also various measurements and see how the frequency affects those measurements. For example, if you were to select the dose, right, in the measurement tab, you will see the frequency, right, responsible for your highest dose. So if you put this instrument on a worker, and at the end of the shift, it tells you that 2 kilohertz contributes to 100%, or let's say 80–85% of their dose. You know that that particular frequency is what's causing the most trouble. So when you go and work with engineering to implement, or the administration to implement some changes, this can be a hard data to kind of weed through any, objections, or kind of facilitate the conversation with the engineering team. So.
Okay, thank you, Kami. Well, next, we're going to jump into PDOS. So PDOS monitoring gives the administrator critical insight to where immediate controls or mitigation might be needed to limit personal exposure. So in a sense, DOS considers time and dB value to measure overall exposure. PDOS assumes that the work shift is 8 hours and that the noise level will remain constant, right? So it should be used as an indicator for additional analysis, as it's providing an estimated projected permissible exposure. So this is different than DOS that gives you the real-time permissible exposure indicator at any point in time. So for example, some users might be exposed to higher dose earlier in the shift. This would obviously greatly increase the PDOS exposure estimates for that individual. This data can be used as an indicator to further examine specific user exposures by implementing additional tests such as audio event recording, ceiling count, octave band analysis. All can be used in conjunction with PDOS to truly understand what's causing those exposure estimates to be so high.
Exactly. And when it comes to PDOS, in the noise hazard, the department, their industrial hygienist or the safety professional can't really take any action in the moment, because you really want to collect the data, then do an analysis and see what changes you might want to implement and so forth. Now, in heat stress, for example, people are affected in the moment, and something bad might actually happen. So it is imminent to take action right away. Unfortunately, in the noise hazard department, you can't really, there's nothing there to tell you whether or not you might want to take action right away. Now, PDOS here is projecting the current dose that the individual is accumulating and telling you, well, if the noise level stays constant, right? That's one assumption for PDOS. If the noise level stays constant, then this individual is projected to surpass the allowable 100% dose, right? So if you run a shift for 2 or 3 hours and see a PDOS of 150 dB, it might be a good, good idea to supplement some hearing protection device, or simply move the worker to a different station, right? So, so this is the kind of what PDOS offers to the user. Now, on this slide, there's a projected time calculator panel, and what this really does is, when you go through the hierarchy of controls, some of the issues that safety professionals run into is that they collect the data and they make suggestions to the administration, suggest that they change the way that people work, but the administration really needs something to back, or so some kind of tangible data to back the suggestions. This can be one of them, right? So if I collect a sample for 8 hours and I suggest that the workers spend, let's say, 4 hours at one location, and then move over to a different location for 2 hours, and then come back here for another 2 hours, without affecting the productivity of the workplace, that might be a good suggestion, but there's a million ways that one can switch things around, right? So you can simulate all those different little swap of worker around with this little panel. So at the bottom there, the projected time here, not sure you can see the cursor, but the projected time there that says 12 hours can be changed to any amount of hours that you'd like. And then when you press apply, you can now recalculate the new values of the TWA, the projected dose, and so forth to give you what your estimated measurements would be, if the individual were to spend more time at the same place or less time at the same place, given the same noise level. So now let's talk a little bit about the DMS software that we've been covering so far. So the DMS software really is a powerful tool for all the Quest line of instrument. And with 7 and 8 dosimeters, the DMS software is fully capable and compatible. The user interface has not changed. If you are a legacy user for the Edge 4 or 5, it has more capabilities in terms of downloading audio files, doing ceiling count, and enabling and disabling Bluetooth, all via the software platform. Another good tool that we have here with the 7 and 8 is the Edge DB app. Because of the Bluetooth versions on the 7 and 8, users can now see the live data of the subject without sort of interrupting the process of their work. So if you are in a facility where you want to kind of check on a particular individual and see their P dose, for example, when you pull up the Edge DB app, whether on Android or iOS, you can simply see that live data right on your smart device. So,
right. And it should be noted too, you mentioned Bluetooth a few times, but both of these devices will be available in both Bluetooth and non-Bluetooth versions. And when we say non-Bluetooth, we mean there's no capability of that device ever becoming Bluetooth. Technology is not even inside the device. So we know some of our customers have restrictions on Bluetooth technology within devices. So we were cognizant of that when we developed these and made sure that we developed 2 versions of each to accommodate for that. Next up, we'll talk a little bit about how the hierarchies of controls come together a little bit better.
So we've been talking about the hierarchy of control so far, and there's a very good reason for that. We understand that every safety professional or industrial hygienist has a standard of operation, and oftentimes, and in most cases, it is the hierarchy of control. And it not only applies to noise, but it applies to virtually all hazard that you might encounter out there. So it is very important that when you have a tool, a survey tool, that survey tool helps you navigate that top-down hierarchy as fast as possible. Again, noise hazard is not very easy to mitigate. And sometimes you might want to supplement the PPE right out the gate as you go down the list of items to check off, because engineering control might take a month to accept your suggestions, or the administration might take forever to want to change the way people work because of productivity. So really the tools that you need are the best tools out there, should be able to help you navigate this hierarchy efficiently and as fast as possible.
All right, with that, we'd like to open up the floor to questions.
Okay, can you hear me? And I unmuted. Guys, one of the first questions that came in was a question regarding the pause feature, and whether that's a button on the dosimeter itself, or is it only available after the file has been downloaded? So I wonder if you can back up to that for a moment.
Correct. The pause feature is a button on the instrument itself. So if you're familiar with our older dosimeters, you have a run and a stop mode. The Edge 7 and 8 is improved in that manner, where it has a run, pause, and stop. So every time you do a run, pause, the device waits until you resume the study, and you can see that translated on the graph in the software.
Thank you. The next question that came was, is there a distance limit for viewing live data?
So the Bluetooth versions of the 7 and 8 use the BLE5 Bluetooth technology. Now, that Bluetooth technology in of itself is depending on interference and location. So if you're in a facility where there's a lot of machinery going on, emitting various frequencies, that would affect tremendously the Bluetooth range. But in a free field, this BLE technology can go up to 13 feet, I believe, and that's just what the BLE5 low power, long range Bluetooth offers, right? So it all depends on where you use it, but otherwise it's the latest Bluetooth technology available out there.
And just a note that we always encourage anybody, at the end we'll have contact information, but if you have a specific application or consideration, please call and we can answer that specifically as well. The next question is regarding how big the memory is, and what happens if the voice and or audio triggers fill up the memory.
So you can record data up to 100 days, full shift up to 100 days. When you run out of memory in terms of audio, the device tells you, and you see a warning sign on the screen that tells you that you've ran out of audio space. So this means that you'll not be able to record any audio files in your later surveys. And every time you trigger the recording, it gives you that same warning. So we really recommend to download the file after a couple of uses to save that data on your computer.
And it's just simply the same, which brings up both the next question that you can address with this as well. You download it simply by putting it in the cradle, and when you is there a difference between the cradles? Can the old units, the 4s and the 5s, utilize the cradles for the 7s and the 8s?
Great question. So the cradles are different. The 7 and 8, because of the battery requirement, use a different cradle. So the cradle for the 4 or the 5 or all the legacy products in terms of noise dosimetry would not be compatible with the 7 and 8. I also like to point out that the Octave Band analysis is mostly responsible for the battery requirement, but also the audio recordings, right? You can now download these audio files right on your computer, and actually it not only downloads the file within the software, but there's a backdoor to the files that you can send the audios if you'd like, or share the audios if you'd like. So that altogether required a different cradle technology, and that's the reason behind that.
Okay, thank you. Are there, other than the intrinsically safe feature, is everything identical between the Edge 7 and Edge 8, or are there any other differences?
So the Edge 7 and 8 are come fully featured with Octave Band, voice note, auto recording, and the only difference is the intrinsically safety. The Edge 8, the orange color, is the intrinsically safe model, and the blue is the Edge 7 and the non-intrinsically safe model. Maybe this is a good time to point out that the color difference is really to show from a distance that the subject or the worker is wearing the appropriate unit. You know, all our legacy products, you know, if you put a 5 and a 4 together on the same table, or any other devices out there in dosimetry, really, there's really no way to identify the intrinsically safe from the non-IS, right? And you have to interrupt the worker, pull the device from their shoulder, turn it over to see the IS marking in the back, right? But with the orange color, you can clearly see it from a distance, and that's really the design, the reason behind that design aspect.
Awesome. A question came up regarding the software and what versions of DMS includes these models. So again, for legacy users and so forth, do they need new software? Can they get a download, or can they get an upgrade, or how does that work?
The software really is available for update on our website. So for legacy users, all they have to do is go on the website through the portal and download the new version of the software. The old version of, if you are a legacy user and have an older version of DMS, DMS simply would not be able to recognize the 7 and 8, right? So it is, like I pointed out, the user experience and the platform is virtually unchanged, but in the background, the technology that drives the audio, the Bluetooth, and all the new added features require that update. So it's all available on the website.
Okay. Question regarding battery life. What is the battery life for taking, measurements under? And I'll leave that to you. I know it's variable based on what you're doing.
Correct. So, just like any device you have, whether it be a phone or any other device out there, it depends on the log rate that you use, that you set the parameters to. The Octave Band analysis, the automatic audio trigger recording, and whether or not, this is very important, whether or not you leave the screen on, right? There's a feature in DMS where you can automatically set the screen to a certain, time shut off. So after a certain period of time, it'll automatically shut off. And you can also leave it where it turns off completely the instrument if it's not being interacted with. Well, obviously this doesn't happen when the device is in pause mode or in run mode. Only when it's in stop mode, it would completely shut off. But nonetheless, you have a 30-hour battery life on the instrument. And even with all the features turned on, all the power hungry features that I just mentioned turned on, you can still do a full 12-hour shift on any of the instruments, 7 or 8.
Okay. Can the Edge 7 and the Edge 8 come with the MEMS microphone and a larger microphone? Can you take a moment and explain the differences and, you know, what they can expect from the new microphone?
Absolutely. We received a lot of feedback regarding the microphones, especially on the Edge 5. The Edge 5 had a quarter-inch microphone, and really, when we make our microphones to be field replaceable, that means when you have a microphone issue, all you have to do is order a new one, or a lot of our customers have a backup microphone that they can just swipe on with the damaged microphone. The issue here is that when you the older microphones were not only quarter-inch, but they were twist-on microphones. So it allowed the membrane of the microphone to be compromised quite often. So the half-inch microphones are MEMS microphone technology. And the MEMS technology is an acronym for micro electromechanical system. Really what that means is there's a membrane at the top of the microphone that vibrates to sound pressure level. And that pressure level is converted into voltage, and that's later amplified and then turned into analog, digital signal that you can see on the screen or download onto your computer. So they're made this way to be more robust because the MEMS microphone require a set of tiny components that makes them more robust and also less power hungry. So you have the dual effects of the robustness and the energy efficiency with the half-inch MEMS microphones.
In a related question, regarding the windscreens, will they stay on securely and not come off easily during testing?
Absolutely. The windscreen, and if I can mention something else on the microphones, I said that the quarter-inch were twist on, and that caused a lot of damage. These half-inch MEMS microphones are snap on, snap off. So we designed it in a way that you can take it off and snap it off and put it back on instead of twisting. Same goes with the windscreen. The old windscreens were twist, and the newer model are snap on, snap off. And yes, they are harder to come off, or to come off the microphone really when used in the field.
But we're also aware that some of them may be lost at times, so we're sending spares with each unit.
Correct. In each package.
Jason, you're kind of soft in the background, just to let you know.
Oh, no, I said, yeah, we're also aware that sometimes these will be lost nevertheless, right? So we are sending spares with each unit.
Okay. Regarding the dosimeter attachment clips, the question is, have they been improved? For example, on the Edge 5, they would not attach to Tyvek suits.
The 7 and 8 have the same clips that the legacy product had. The only difference now is that because the 7 and 8 are light, they can sustain some of the issues that we had with the older version easier. So we hope that the issue that some of our customers had with the clips would be eliminated by the slight difference in weight of the instrument.
Okay. Regarding the calibrators, will these work the same with your, either the AC300 or, any other calibrator that?
Absolutely, yes. The AC300 is the one calibrator for all Quest noise dosimetry instruments. So whether you use a Sound Pro, an older Edge 4 or 5, or the current Edge 7 and 8, the AC300 is still the calibrator to use. It is compatible.
Yeah, each unit will be coming with a new adapter to be used with the AC300. 1/4-inch versus 1/2-inch microphone. Obviously, call for that updated adapter.
Correct. So for our customers who have a fleet of 5s and 7 or 8 here soon, they can easily navigate the calibration between the two fleet.
I am not seeing any other questions, so let me just give it a minute and make sure that there's no other questions coming in. And if not, we are just past 45 minutes, which is good. So if there are not any other questions, I'd just like to take a moment, and first of all, I'd like to thank Jason and Comey for taking the time for your presentation and sharing your expertise with us. If anyone has any specific application questions, I've got my contact information up on the screen. Please email me or give a call. It's got our company number, so you could ask for me or you can email me, or I know a lot of people that are on the webinar know me as well. So please let me know if you have any specific questions and we'll be sure to get them answered. To answer anybody's question they had earlier, this is being recorded. We'll send you a copy of it. Plus, you can access this on Lesman's website under webinar, along with endless other webinars that we've done in the past on many different subjects that may be of interest to you. They're always available to you. In addition, if there's anything that you would like to know or you would like us to put a webinar together on of a different subject, please email me that as well. We've got many partners that are anxious to help do educational webinars. So at this point, if there's no other questions, I thank everybody for taking their time and being with us, and I wish you all a great afternoon. Thank you, Jason and Comey.